नमस्ते बच्चों, हमेशा खुश रहो बच्चों। माई सेल्फ ओम प्रकाश, फैकल्टी ऑफ डिपार्टमेंट ऑफ मैथमेटिक्स अंडर फैकल्टी ऑफ एजुकेशन एंड मैथोलॉजी, ज्योति विद्यापीठ यूनिवर्सिटी जयपुर. Today I taught you group theory, which are the subject of mathematics under science stream, and which are taught in BSc BA PCA 6th semester student, and also BSc 6th semester student. These are the lesson planning which are already discussed in your first lecture. Planning relation which are already discussed in your first lecture. Now the components of relation planning which are already discussed in your first lecture. In group theory, I will see some more theory, and lot of things such as non-wide, semi-group, abelian group, and then concept. Today I taught you the basic terms of concepts. Now, before giving introduction of concept, we first define some basic terms which are already discussed in the number theory of opposition class, which are congruent modular in I will see congruent modular in number theory. Today I will see congruent modular in equity. If A congruent to B modulo M, A congruent to B modulo M, which means that A minus B is divisible by M. A minus B is divisible by M. Or we can say A minus B by M equals to K, A and integer, where K is an integer. Where K is an integer. This concept will be used in group theory also and is known as congruent modulo in group theory. Here we define congruent modulo in group theory as let H be a subgroup of a group G. Let H be a subgroup of a group G. For any elements A and B belongs to G, we say that A is congruent to B modulo capital H. As we say, if AB inverse belongs to H. If AB inverse belongs to H, this is the condition which are of the subgroup which are taught in the last theorem. Mathematically, we write A congruent to B modulo H. This relation is an equivalence relation. Corresponding to this equivalence relation, we get equivalence class. We get equivalence class for any A belongs to G. The equivalence class of A is denoted and defined by class of A equals to X belongs to G, such that X congruent to A modulo H. X congruent to A modulo H, where A is the element in G. H congruent to A modulo H. That means the collection of all congruent modulo in H. Collection of all congruent modulo in H. Now, next I will define the new term which are known as Q6. 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 Let H be a subgroup of G. Let H be a subgroup of G. And let A belongs to G be any element. Then capital H small a. Capital H small a equals to small h small a such that H belongs to H. Small h small a such that H belongs to H is called the right coset of H in G. Is called the right coset of H in G. Similarly, we can define the left coset. Here, for left coset, small a capital H equals to small a small h such that small h belongs to H. Such that small h belongs to capital H. Here we similarly define the right coset or left coset, or simply we can say it as a coset. When the element will be multiplied from the right, it will said to be right coset. If this element is multiplied from the left side, it is said to be left coset. Now, let us see one theorem on cosets. Any right coset of H in G is an equivalence class. Any right coset of H in G is an equivalence class, or simply for any A belongs to G, we have to prove that H capital H small a equals to class of A. Capital H small a equals to class of A. For proof of this theorem, let X belongs to HA. X belongs to HA. Then X equals to small h small a for some H belongs to capital H. H A inverse equals to H. X A inverse equals to H. By multiplying both sides with inverse, we got X A inverse equals to H. This implies that X A inverse belongs to capital H, and we can finally say X congruent to A congruent model on H. This implies that class of. This implies that X belongs to class of A. Thus, we can see that if we take any element from HA and class of A, therefore HA is a subset of class. We take this as equation 1. Again, let X belongs to class of A. That means reversing this process. X belongs to class of A, then X congruent to A modulo H by definition of class of. This implies that X inverse belongs to capital H. This implies that X A inverse equals to small h for some H belongs to H. This implies that X equals to HA. X equals to HA, which belongs to capital HA. Therefore, we can say that if we take an element from class of A, we got that element also in from right coset. Therefore, we can say that class of A is a subset of right coset H. Therefore, we say from equation 1 and 2, H equals to class of A. That means any right coset of H is in G. Therefore, we can say that any right coset of H in G is an equivalence. Any right coset of H in G is an equivalence class. Here some notable points are there. Any two right cosets are either equal or have no element in common. Any two right cosets are either equal or have no element in common. And also that union of all the right coset of H in G will equal to G. And the second one is the a coset is not horizontally a subgroup. A coset is not horizontally a subgroup. If G be a quaternion group, then H equals to 1 minus 1. G is a subgroup of G, then A equals to I. Then we can take H equals to I minus I. This is not a subgroup of G. G because it doesn't contain identity element. It doesn't contain identity element. That means finally we can say that every coset is not horizontally a subgroup. Every coset is not horizontally a subgroup, but every subgroup have a coset. Sorry, forms a coset. Group forms a coset. This session was powered by the digital version 2.0. So
University, Jaipur, and I hope all of you are satisfied with my digital question. If you have any queries, please mention in the comment box. I will try to resolve. Thank you for watching my this lecture video. Thank you.